Yeah, hi everyone. In this video, I am going to explain the importance of calculus in action. That means the importance of differentiation and integration in our daily life. So what is differentiation? So what is the logic behind the differentiation? So the core idea behind the differentiation is measuring instant changes. That means how the function f of x is going to change right now. So what it measures? It measures means the slope of the tangent in the geometry. Okay. So when the slope is positive, that means the function will rise. When the slope is negative, then the function will fall. When the slope is 0, then the function is having local maxima and local minima at that point. So if you look at that diagram, the curved shape line is the curve, and the straight line is the tangent, and the dot point is the slope. So at that point, the curve has the local maximum. So this is a small application which is related to differentiation in the geometry. Next, coming to another slide, integration. So integration means accumulating quantities. That means total amount built up over an interval. So it means the integration means the antiderivative. That means it measures the area, volumes, surface area, etc., etc. So if you look at the diagram, the curve is bounded with x-axis, and in between the x-axis and the curve, some part is shaded, and that the shaded part may be area or volume, etc., etc. Okay. So area above x-axis, positive integral; area below x-axis, negative interval. Total net change is f of b minus f of a. So this is the small application related to integration in the geometry. So what do you understand with this small diagram? Integration will be useful to measure the area or volume of a surface. So now I am going to explain some real-time applications which are relevant to our daily life based on the differentiation and integration. First application is GPS and navigation. So in our daily life, we will travel from one point to another point, or from one destination to another destination. So for this, we will book either Rapido or Ola or some other applications we will take work. So GPS and navigation, how they will work, and what is the differentiation and integration concepts involved in GPS and navigation. So GPS satellites timestamp signals. Your device computes the position s of t, then differentiates to get velocity, that is v of t equal to ds by dt. So in the GPS and navigation, we will apply some formula, that is speed. The speed is nothing but ds by dt, that is v of t. Next, acceleration. The acceleration is nothing but a of t, that is dv by dt. Next, higher derivative reveals traffic prediction. So the real impact of the differentiation and integration: turn-by-turn navigation, speed camera alerts, ETA calculation, and autonomous vehicles guidelines all depends on these derivatives updated multiple times per second. So just see that slide or diagram. There are some curves. They are the path of our destination. Okay. So the path of the destination will work based on the GPS and navigation, and the GPS and navigation will work under the concepts of differentiation and integration. Okay. Next, application to electrical circuits. In our daily life, we require the power, that is current. So the electrical current is defined as the rate of charge flow. So that is, the current is I of t, that is the rate of change of the charge flow, that is Q, that is dq by dt. So more charge moving per second, more current. In AC circuits, Q equal to sine of omega t, that is charge equal to sine of omega t, so that the current I equal to omega into cos omega t. The 90 degrees phase shift between charge and current comes directly from the differentiation. So by using the concepts of differentiation and integration, we will calculate the current or charge, etc., etc. In engineering use, capacitor charging or discharging, signal analysis, filter design and power electronics all rely on dq by dt and integration IDT relationships for accurate circuit modeling. So if you look at the diagram, they are the flow of the current. The curves represents the flow of the current. So this is a small application which is relevant to differentiation and integration in electrical circuits. Next, application 3, in civil engineering. In civil engineering, where do we apply differentiation and integration? So integration behind movement from shear force distribution. The concept of integration involves in the civil integration is bending movement from shear force distribution. Beam analysis. For a beam with distributed load W, the shear force V of x, that is R minus WX, and bending moment M of x equal to integration Vx dx. So in that beam analysis, there are two formulae, that is V of x equal to R minus WX and bending moment M of x equal to integration Vx dx. So here we are seeing integration and differentiation. And next to key formulae. So V of x, what does V of x? That is dm by dx, derivative relation. M of x equal to integration V dx, that is integration relation. So maximum M occurs whenever V equal to 0. Okay. So in the real impact, every bridge or floor slab or a root truss is designed by integrating load distributions. Safe structures depends on locating maximum bending moment and the calculus of safety. So this is the small application in civil engineering which involves the concept of differentiation and integration, especially movement from shear force distribution. Next, fourth application, game physics and projectile motion. So what is game physics and projectile motion? So it involves the concept of differentiation, that is linking position, velocity and acceleration. So here velocity and acceleration involves in the game physics and projectile motion. So what is physics engine? Every game engine updates objectives positions by integrating acceleration twice. That is the acceleration A equal to V equal to integration of A dt or Y equal to integration V dt per frame. So projectile chain, A of t means acceleration, that is minus g, that is gravity, and V of t, you know it well, velocity with respect to time, that is integration of A dt, that is integration of acceleration with respect to time t, that is V naught minus gt. Next, Y of t is the displacement, that is the integration of V dt, that means the rate of change of the velocity with respect to time t, that gives the displacement, and that is equal to y naught plus v naught into t minus half gt square. So the real impact is realistic ball trajectories, character jumping, arcs car handling and bullet physics in AAA games all solve these differential equations 60 plus time per second in real time. So here also we are seeing very clearly in the game physics and projectile motion, the differentiation and integration concepts are involved with respect to velocity, acceleration and displacement. Next, fifth application, population dynamics. So day to day, the population is increasing throughout the world. So how it increases and what is the concept of differentiation and integration involved in the population dynamics, that I am going to explain. So growth model, if you take the growth model, the simple ordinary differential equation is dp by dt equal to r into p. So if you solve this differential equation, then we will get the solution is p of t equal to p naught into e power rt. That means the rate of growth equals r times the current population. So the growth of the population depends on the current population. What r measures or what r means? If r greater than 0, exponentially growth. That means bacteria and investments. So if there are 500 bacteria, after some times it increases to 1000 bacteria. And if you deposit 500 rupees in a bag in a saving account, after some time it increases to 550. Okay, so that is related to r greater than 0. When r less than 0, exponentially decay, that is radioactive isotopes and drugs. Okay, when the population increases, then the eatables or medicines may be very expensive. If they are expensive, and automatically their production will reduce. Okay, that is related to r less than 0, that is exponential delay. When r equal to 0, constant population. That means if there is no change in the present population, then we can see the constant change in the growth of the population. If you take this some real impact, epidemiologists used dp by dt models, that is SAR equations. Recently, the Union Government of India is applying SAR in every state. During COVID-19, to predict infection peaks, the same calculus underpins carbon-14 dating, drug of lives, and component interest. So these are the small applications which are related to population dynamics and which is having the concept of differentiation and integration. Next, sixth application in medical field or in the pharmaceutical field, how we are going to apply the concept of differentiation and integration. The motto is modeling drug absorption, peak and elimination. In the drug model, we will apply the concept of differentiation. So after oral dosing, concentration rises, absorption then fails, then the curve C of t is found by integrating two exponential processes. Key concept, if you take the key concepts, dc by dt equal to 0, peak concentration, and integration c dt equal to AUC, that area under curve, that is total drug. The area under the curve represents the total drug. Exposure used in diagnostic decisions. If you take its real impact, every antibiotic dose interval, cancer, chemotherapy, protocol and anesthesia calculation is based on the pharmacokinetic calculus, wrong doses, toxicity or treatment failure. That means for a disease we use it to take drugs, but the doctors will suggest how much quantity that we have to take to cover from the disease well. That depends on the rate of change of differentiation or integration. Okay, so this is an application in the medical field. Next, seventh application, heat transfer. So what is the motto behind the heat transfer? That is a differentiation. That is a Fourier's law. Heat flux from temperature gradient. What is Fourier's law? Q equal to minus K into dt by dx. That means heat flows from hot to cold. The minus sign confirms flow opposite to the temperature gradient, that is related to derivative. And the heat equation is dou T by dou T. Your capital T represents temperature and small t represents time. So that equal to alpha into dou square T by dou x square. The x represents in the direction of x-axis. So this is a partial differential equation that represents how temperature evolves over time and space. So this is a small application in the heat equation. What is its real impact? CPU thermal management, building insulation, ratings, specified heat shields, and refrigerator design all solve these differential equations. Without calculus, modern electronics would overheat. Okay, so in the heat transfer also, we will apply the concept of differentiation, that is heat equation or Fourier's law, etc., etc. And if you take some formulae which are relevant to differentiation and integration, just look at this slide carefully. GPS navigation, it works under the concept of differentiation. Its key formula is velocity, and what is its computes? Velocity and acceleration. Next, electrical circuits. In the electrical circuits also, the concept of differentiation involves, and the power will be calculated as dq by dt. That means current from charge. Civil engineering. In the civil engineering, we applied the concept of integration, that is bending moment, that is m of x is equal to integration v of x dx, that is bending moment. Game physics. In the game physics, we have applied both the concept of differentiation and integration, that is y equal to double integration of a dt square. This means position from the acceleration. Next to population and biology. In the population biology, differentiation concept is applied. The dp by dt equal to rp. It means exponential growth rate. Next to medicine, that means drug model. In the drug model, we applied the integration concept, that is AUC equal to integration CT dt, that is total drug exposure. Next to last one is heat transfer. In the heat transfer, we have applied differentiation, that is Q equal to minus K into dt by dt. It represents heat flux in the direction of x-axis, that means in a single space. So finally, I can say calculus is everywhere. So every derivative you learn is a key to the real world. From GPS to game engines, from medicine to bridges, thus universe speaks calculus. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.